Okay, so when most people think of the brain, they think of the outer layer. That outer layer is called the cortex, and that's the part that really makes us human. That's the most recently evolved part of the brain, and in humans it's by far the biggest. And the cortex is divided up into several cortical regions, and each region in a different part of the brain does sort of different things. And they're all connected through other areas of the brain, also in the cortex, called association areas, that allow us to unite, what we see with what we hear and all this sort of thing. Deeper in sort of the center of the brain, the parts that you don't see, that's the old, sometimes it's called the reptilian brain, or the midbrain, the hindbrain, the brain stem. That's parts of the brain that are older and that you'll find in most animals. And that's parts that regulate things like breathing and heart rate and digestion and all these sorts of things.
Differences between left and right brain? only if you've
Right, yeah, that's a tough one. I think like any of that sort of folklore has a grain of truth, but I think it's been overstated. So people have been trying to reproduce intelligence. Defining intelligence is another issue. It's something that we recognize it when we see it, but it's very hard to pin it down. But people have been trying to build, automatons for centuries, and then people started getting a little more nuanced, and they started looking at symbolic representations, how the brain processes logical statements and makes inferences. And so AI for quite a while was focused on purely symbolic logic and trying to reproduce cognitive processes through logical equations, basically. That works a little bit, but not terribly well in the real world, because the real world is full of shades of grey. And that led to things like fuzzy logic, where things can be true or false or anywhere in between. And again, that worked a little bit better. But then people started taking inspiration from how the brain is actually architecturally constructed. So with neurons, billions of neurons, little tiny things that all talk together. And that's where neural networks came from. And again, neural networks went through several periods where they seemed to work, and then people worked out, it doesn't really do as much as it should. And then along came in the 80s this technique of backpropagation, which is a way of training quite large neural networks to do some very interesting things. It's a mathematical technique. But again, it didn't really lead to what it promised, because for two reasons. We didn't have the computational power to do networks the size of the brain, and we didn't have the enough training data. But both of those things have changed just recently with the increase in computing power that we're currently seeing, and with the internet. Now we have access to huge amounts of training data. And that's where the current brain-inspired AI has come from.